Any questions about this one? Okay, so the next thing that I want to talk about tonight is these are the things that you already know from Khan Academy. The measures of central tendency. I'm just giving you a reference so that you can come back after and look at them. So there are three measures of central tendency. There is mean, median, and mode. Yes. So what are these measures of central tendency? What is the formula? How you can calculate these measures of central tendency? These are called measures of central tendency. So they're called measures of central tendency or measures of central location because they point towards, or they point towards the middle of the data in different ways. They point towards the middle of the data. So one of them is the mean, or the arithmetic mean is the arithmetic average. You already know how you can calculate that one. You just need to add up all the numbers and divide it by the sample size. So imagine you have a sample of size n. Sample size n. So these are your sample x1, x2, x3, all the way to xn. So these are the measurements inside your sample. Your x bar is going to be, you just add them all up and you divide it by the sample size, which is going to be n. Yes. However, in statistics, we don't use big expressions like this. We're using a short notation for adding up all these numbers, which is called the sigma notation. So rather than writing x1 plus x2 plus x3 all the way to xn, we use a symbol like this. It's called sigma. It's actually the Greek sigma. And we use an index, usually I, and we go that this index goes from 1. So I is first 1. And finally, it's n. And then here we put xi. So for example, if I say sigma, let's say I from 3 to 7, I mean A3 plus A4 plus A5 plus A6 plus A7. So rather than writing this, which is long and cumbersome, I just use a shorthand notation, which is called the sigma notation. Another example, if I have, for example, sigma xi squared, I from 1 to n, what does that mean? That means x1 squared plus x2 squared all the way to xn squared. It means that. Are we good? So the formula for x bar is going to be sigma xi divided by n. So x bar is sigma x divided by n. That's called the sample mean. Any questions? So imagine we want to find the sample mean here for this data. We're going to calculate the sample mean using the frequency table. So this frequency table, it is telling us that 0 has been repeated 3 times. So it's like having 0, 0, 0. And then 1 has been repeated 6 times. So 1, 2, 3, 4, 5, 6. And then 2 has been repeated 6 times. 1, 2, 3, 4, 5, 6. And then 3 has been repeated 3 times. And finally, 4 has been repeated 1 time. Now I need to just add up all these numbers add up all these numbers and divide it by the number of the sample size, the number of the numbers. So if you look at this frequency table, X or XI, FI, 0 has been repeated 3 times, 1 has been repeated 6 times, 2 has been repeated 6 times, 3 has been repeated 3 times, and 4 has been repeated 1 time. And all in all, the sample size N is 3 plus 6, 9, plus 6, 15, plus 3, 18, 19. So there are 19 pieces of data, yes? So rather than doing this, if I say X bar is equal 0 plus 0 plus 0 plus 1 all the way to plus 4 divided by 19, I can do something else. I can say I'm gonna multiply the xi and the fi. I multiply them. So when I do 0 times 3, I get 0. That would be the sum of these 3 numbers. Then I multiply 1 and 6, I get 6. That's the sum of these numbers. That sum is going to be 0. That sum is going to be 6. Then I multiply the 2 and the 6, I get 12. That's the sum of all the 2's. I multiply 3 and the 3, that would be the sum of all the 3's, 9. And I multiply 4 and 1, that would be the sum of all the 4's. Yes? Then I can just add up. I can just add up all these numbers and divide that by 19. 0 plus 6, 6 plus 12, 18, 18 plus 9, 27, 27 plus 4, 31. So 31 over 19, that is my sample mean. Yes. So now we have a new formula that is good for a frequency table. If you're dealing with a frequency table like this, in order to get X bar, you can use this formula, sigma xi fi, which is the sum of these numbers here in this column, and you divide that by n. And you can see that n, the sample size, is simply sigma fi. If you just add up all the numbers here, you get n. Is that clear? Any questions? Okay, so we have 2 formulas for X bar. If you have the list of the numbers, you just use this formula. But if you have a frequency table, you can use this formula. And in your frequency table, the sample size n is simply the sum of all the frequencies. If you just add up all the frequencies, you get the sample size. So for this one here, if to get the sample size, I just need to add 3 plus 6 plus 6 plus 3 plus 1. If I just add up all these numbers, the frequencies, I get 19, which is also the sample size. Any questions? Let's talk about median. Oh, by the way, there is also something called the population mean. What is the population mean? For any of these things, we have a population and we have a sample. So we have mean, median, and mode. Yes, we have sample mean, which comes from the sample, and we have the population mean, which comes from the population. If you have just a sample, you're going to use this formula to calculate the sample mean. But imagine if you have all the information about the whole population. So you have the measurement, a certain measurement for every individual in the whole population. Then you can calculate something called the population mean, which is going to be sigma xi divided by uppercase N, where uppercase N is your population size. Make sense? It's basically the same formula. You just add up all the measurements in the sample, divide by sample size, or you add up all the measurements in the population and you divide that by the population size. This you can only calculate if you have all the information about the population. What do you get? You get the population mean, which we represent by mu. This is how you read this. Mu is the population mean, which is sigma xi's divided by uppercase N. And you can only calculate it in most practical situations. You cannot calculate that because you don't have the measurement for all the individuals in your population. But if you have the measurement for every individual in the population, you will be able to calculate your population mean, which is a parameter. Yes? If you remember, we said that a feature of the population is called a parameter. We're good? Questions? Okay. Next, we talk about median. The median is simply the middle number. Median is the middle number. And in order to calculate, it's another way of measuring a measure of central tendency, and the sample median. So sample median, we use x tilde for that. And this is how you calculate the median. You're going to either have n is odd. For example, n could be 7. Or n is even. For example, n could be 6. Yes? So the first thing you do, you order the numbers. So imagine you're dealing with the grades of 7 students and you're looking for the median. Let's say the grades are like this. 67, 72, 75, 80, 85, 1, 2, 3, 4, 5, 6, 7. So you just order the numbers. So that's the first thing that you have to do. You have to sort the number. The numbers must be in a sorted order from the smallest number to the biggest number. And then if you have an odd number of individuals in your sample, there will be one middle number. So here in this case, 80 is the middle number. There are 3 to the left, 3 to the right. So that would be your median. But if you have an even number of individuals, so imagine you have grades 70, 72, 85, 90, 95, 97, 1, 2, 3, 4, 5, 6. Then there is no middle. There are actually 2 numbers in the middle. So what do you do? In order to calculate the median, you would just add up the 2 numbers in the middle and divide by 2. You're going to get 87.5. So in this case, the median would be the average of the 2 numbers in the middle. Make sense? Any questions? Okay. You already learned this stuff from Khan Academy, am I right?
Yes, sir.
Yeah, and I'm just reviewing this stuff. So hopefully, if you have any questions, if you did not understood, if you did not understand something from Khan Academy, you can ask me. And if you have a frequency histogram, if you have a frequency histogram, if it's a relative frequency histogram, the median would be like this. That is, since it's the middle number, 50% of the data would be less than the median, less than or equal to the median, and 50% would be greater than or equal to the median. Make sense? So you can say one definition for the median, you can say the median is the middle number, so that at least 50% of the data is less than or equal to the median, and at least 50% of the data is greater than or equal to the median. Okay, so here you have some examples. I gave you examples, so you should have no problem. Now, this is very, very important topic, and you had some exercises like this in Khan Academy. Sometimes your relative frequency distribution is symmetric. Like in this case, imagine you have a relative frequency for your data, and it's a bell-shaped distribution. And as I said, this is very common in statistics. This is called the normal curve. And for many data, like for example, height of organisms, could be individuals, could be animals, any organism, weight of organisms, like for example, weight of people, weight of fish, weight of poultry, chickens, whatever, weight, grades, which only makes sense for humans, IQ of humans. For most of this type of data, if you draw a relative frequency histogram for a relatively large sample size, it's going to be the shape of a bell. It's a bell-shaped curve. And it's symmetric. It could be symmetric like this, or it could be symmetric like this. This is also symmetric with respect to the middle line here. It's symmetric. If you have a symmetric distribution, then in a symmetric distribution, the mean, the sample mean, and the sample median are going to be almost equal. Make sense? They're going to be almost equal. However, sometimes you have distributions that are not symmetric. So you can have a distribution that is like this. If you have a distribution that's like this, it means that you have some data that are rare in the high end. There are some data here in the high end that are rare because the frequency is small, yes, but too large, rare and too large. For example, this could be about, this is true about income. There are some people who are not very common, they're rare, but they have very, very big income. For example, in Canada, if someone has an income that is over $100,000, that would be considered to be a very big income, but it's not very often, it's very rare. A very small percentage of the people in the society have an income that is over $100,000. Yes, so this type of data are called outliers. Outliers. And outliers, they have a big effect on the mean. Outliers affect the mean. But the thing is, outliers do not affect the median. So what happens in this situation? These outliers, they are gonna pull the median towards themselves. So the median, sorry, the mean is going to move towards the outliers. So in this case, the mean is going to be maybe around here, but the median that is not affected by the outliers is going to be here. So for this scenario, the mean is going to be greater than the median. The mean is going to be greater than the median in a situation like this, if you have the outliers on the right. However, you can also have outliers on the left. You can have a situation like this. In this case, here you have data that is rare and too small. That's because this is the x-axis, right? Here you have the big values, and here you have the small values. These are also called outliers. And these outliers will pull the mean towards themselves. So maybe the mean is going to be around here, but the median is not affected by the outliers. So in such a scenario, the mean is going to be less than the median. See, the mean is around here, the median is going to be bigger. So do you understand the difference between these two? In this one, the outliers are in the high end, so they will pull the median towards the mean towards themselves. So the mean is going to be bigger than the median. In this one, the outliers are in the low end, so again they will pull the mean towards themselves, so the mean will be smaller than the median. Yes. So what you need to understand here is that outliers affect the mean, but they don't affect the median. You're good? Any questions? Okay, mode is very easy. It's simply the data with the highest frequency in the set. So that's the mode. The sample mode of a set of sample data is the most frequently occurring value. So for example, here, when you have the highest bar, or the tallest bar will give you the mode of the data. And that's the end of the measures of central tendency. You're good? These are the exercises, and the exercises, they also come with the answers.